All right, so we're going to go over test 2 here. And we start with a limiting reactant problem. So that's what this is. We're trying to find limiting reactant. And really, first we start with solution stoichiometry. So I have 1.2 moles of lead hydroxide and an unlimited amount of sulfuric acid. How many moles of H2O will I make? So we're trying to get from lead hydroxide to water. So the way we do that is I have 1.20 moles of PbOH4. If I go to my problem, I see for every 1 mole, I make 4 moles of water. So 1 mole of PbOH4 is 4 moles of H2O. So you just multiply 1.2 by 4 and get 4.8 moles of H2O. Same thing with B. I have 130 grams of H2SO4. Then I go to the molecular weight, which I gave you there. So 98.079 grams in 1 mole. Again, I'm in H2SO4 here. So to go to water, I see that for every 2 moles of H2SO4, I make 4 moles of water. So 2 mole H2SO4, 4 mole water. Then I want grams of water. So for every 1 mole of water, that's 18.02 grams. And you calculate that out. C, I have 1.2 moles of lead hydroxide, 130 grams of H2SO4. What's my limiting reactant? All right, so in A and B, I actually set you up for C, right? If you knew what you were doing. You didn't have to do any calculations in C. What you should find is that H2SO4 makes less water than lead hydroxide. So the limiting reactant is H2SO4. Your theoretical yield is how much H2O you're making. Because the idea is you're mixing PbOH4 plus H2SO4. The H2SO4 runs out. It's all reacted. You have 0 left. And then the amount of water you can make theoretically is based on how much H2SO4 you have. D, based on your answer in C, if I got 1.5 moles of H2O in my reaction, what is my percent yield? If you didn't answer C, say that percent yield's 10. So I'm just going to do that. 1.5 divided by 10 multiplied by 100%. So that's our question 1 for us. Question 2. If I have 46.6 grams of mercury chloride, what's molarity? So I need to take my mercury chloride, that's in grams, and convert that into moles, right? So I get amount of moles of mercury chloride when I do that. And molarity is moles divided by liters, so divided by 3.935 liters. All right. So 3, if I have 2.96 molar solution of mercury chloride, I want to make a 0.19 liter solution that has a molarity of 1.34. How much do I need? So this is dilution. We are diluting 2.96 to 1.34. So that's M1V1 equals M2V2. So I have 2.96. I want to make 1.34 molarity, that is 0.194. How much my original one do I need to make? So V1 equals 1.34 multiplied by 194 divided by 2.96. And when you go look at your test, the answers should be there. And all your numbers will be different. They're randomized for everybody. But that's how you solve it. All right. When you dissolve C6H6 in water, it will produce an electric current. That's false. This is only covalent bonds. MgF2 is true because it has ionic bonds. Remember, to make a current, what happens is that you have to break apart into a cation and an anion. So ionic bonds will do that. Same for aluminum sulfate. That will create an electric current. All right, 7, if I mix these ions, what insoluble compounds will I make? You need your chart for this. OH basically makes insoluble compounds. That acetate doesn't really, chloride doesn't really, OH does. But OH, if it's mixed with lithium, that's soluble. So what is not soluble is barium and cesium with OH. So that's BaOH2 and CsOH. The way I graded that is you got +2 for every right one you got, -2 for every wrong one you got, but you can't get a negative score. Question 8. For this reaction, give me the complete ionic. So you're just breaking apart every aqueous compound. So manganese is +4. And I know it's +4 because it's bound to 4 chlorines. Chlorine is always -1. This is a neutral compound. So the math is X, which is Mn. What's the charge of Mn? If I add that to 4 -1 charges, and that has to equal 0, well, it has to be 4. And don't forget the state signs like I did, aqueous, aqueous, plus 4 potassium. So I said this in class, but group 1 metals are always by themselves, so it'll never make K2. Plus SO4, 2-. This is one of these polyatomic ions I wanted you to memorize. That'll make 4K plus 4Cl plus MnSO4 solid. The net ionic equation is you just see what the same on both sides and you cancel that out. All right, so 4 chlorines, 4 chlorines, 4 potassiums, 4 potassiums. And your net ionic equation is manganese 4+ aqueous plus SO4 -2 aqueous. Oh, sorry, there should be a 2 there. I forgot that. Will make MnSO4 2 solid. Don't forget your state symbols. So that was 8. 9, I'm doing a titration. I need a molarity of H3PO4. So this is basically just like the question we saw above it, but this where we're doing solution stoichiometry with limiting reactant. Here we're doing acid base, right? So what are my knowns? MgOH2, 1.66 moles for every 1 liter. That's molarity. And it takes 0.0441 liters to neutralize our acid, or 44.1 milliliters. H3PO4, we are trying to figure out molarity, and we need 0.002 liters, or it had 0.002 liters. So basically, what we want to do is we want to calculate moles of H3PO4 and take that divided by our liters. So let's try to do that. So conceptually, to go from any other compound in a reaction. So I start in magnesium hydroxide. To go from magnesium hydroxide to H3PO4, I need to be in moles. So if I'm given molarities, oops, that's supposed to be an L. If I'm given molarity, I can just start with how many liters of MgOH2 did I use? So 0.441. Liters cancel out. So now I'm in moles of MgOH2. If I go to my balance equation, I see there's 3 moles MgOH2 for every 2 moles H3PO4. All right, so if I do that, I'll get how many moles of H3PO4 I had in my solution divided by my volume at H3PO4, and I'll get a molarity of H3PO4, right? So that's how we solve that. So oxidation numbers, all right? So this is learning that rules I want everybody to learn. So lead 4+, something by itself, I don't know why I'm writing like that. It's +4, so it's by itself, so it's the charge. By itself is the charge. By itself is the charge. Iron doesn't have a charge, so it's 0. Here, we have to use our rules. Oxygen's always -2. So I'm doing, the math is, I don't know what phosphate is, so I'm going to put an X. X plus 4 times -2. The 4 is because I have 4 oxygens, equal -3. That's the math where the -3 is the charge. So phosphate is 5. Ks, if you look at your rule, the group 1 metals are always +1. That means S is -1. So K is +1. S is -1. Again, to balance out my oxidation numbers has to equal to 0. All right, oxidation number, oil rig. Oxidation is loss of electrons, so if it loses electron, it increases. A reducing agent means it was oxidized, so it's actually increase and increase. So if I'm a reducing agent, that means I was oxidized. All right, and now our last question. So I have a balloon. Its volume is 1.92 moles of nitrogen. The balloon has 1.92 moles of nitrogen, volume of 2.29. I take away 0.56 moles. What's my new volume? So V divided by N, state 1 equals V divided by N, state 2. So I have 2.29 liters and 1.92 moles. What is my new volume? If I take that 1.92 liters and remove 0.56 moles, so V2 equals 2.29 divided by 1.29. And let's see if I can do that math in my head. 1.36. And I'll get your volume. And that's all test 2. As I've said many times, every single question that we've done on this test, we did it in class. So nothing new here. Again, if you didn't do so well, I thank you for watching this video to the end, because right now you are doing what many of your classmates aren't going to do. So kudos to that. But yeah, make sure you're doing the problems. Make sure you are asking me if you don't know how to solve the problems. If you feel like you don't quite get it, and you want some more example problems, there's always more in the book that can help. So if you don't want to ask me, just go to the back of your book, look in the correct section, and you'll find tons of example problems. If you ever do something from the book and want the answer, let me know. If you run out of book problems and you're still like, I'm not sure I got it, then I can always help you find more problems. Yeah. Hope this was helpful for you, and I'll see you in the next video, as I say. All right, take care.